This is the Loctite liquid gasket. If you don't have this tool, you can't do it properly.
Hi guys, Fraser from LIFCO Hydraulics. Here we have a piston pump, a Linde piston pump, that was returned to us because it's different than the original one, the one that they're replacing with. So let's take a look to see what is different about it.
Customer called and wanted one. We supplied them a model code.
Yes.
They're like, yep, that's what we need.
Yeah.
We didn't send them a general arrangement drawing to confirm where everything else is. So if you look at the two, you know, everything's right. The only thing is these have tap servo ports. This one doesn't. Customers using one of them either as a gauge port or an override or whatever they're using it for depending on their system. They can't do it on this one because the port's not there. So they got port here, nothing there. Open port here, nothing here. I'm gonna take the back end off, get it ready for the machine shop. They're gonna bring it back, I'm gonna clean it, go through it, make sure it's all put it back together, test it, make sure everything functions good, and then ship it back to them.
Okay.
So now why do we have these drawings? Shouldn't you be able to just order what you need? Not all the manufacturers have complete model codes. There's lots of things that are not included in the model code. And so what they'll do is they'll give you what is most of the code and they'll put an S at the end. And S means special, and then all bets are off. Now, most customers would never have this information. Nobody would know that this one is a special or that one is unique and all that. So the best way to do is for us to send a drawing of what they have. Now in this case here, we thought it was very straightforward, so we didn't send a drawing. That was an old system. Now we send the drawings every single time.
So the mechanical neutral shims were just hanging up with the liquid gasket here. That's why it was giving me a hard time coming out. So.
And that stuff is?
Yeah, this is the Loctite gasket eliminator. Oh, now we bring this to the machine. Oh, I can. So, in order to do your lube tubes and your mechanical neutral shimming on the HPV, if you don't have this tool, you can't do it properly. There's a predetermined measurement from here to here, or on these, Linde gives it. Then you have to measure this because there could be a slight variation from generational builds. Then I gotta measure a bunch of other stuff. So now, what I'm measuring is I'm measuring the depth from, it should be from the flat, it'll be from the flatness of this, which is measured. So that'll give me my measurement from here to here, so tell me that. Nice, see, I got an 1/8 thou difference, my measurements there. So I've got 1/7 thou there and 1 thou there. So that's why you got to measure both sides.
And that's it for the tool?
That's it for the tool.
Okay, so why are we using this tool if we're just having to do this back end? There was just a little bit of concern over the shimming, and since the unit was here and apart, we might as well just remeasure it, but it appeared to be okay.
This is the Loctite liquid gasket.
The liquid gasket is a very handy tool. There seemed to be a time frame that they were being used in these hydraulic pumps. The problem was it was such a pain to clean.
Does it matter if a little get in those?
I don't want it to be on the O-ring because I don't want it to get behind it and push it up or push it out. So I try to get it as much out of the way as I can. So when I drop it on, it doesn't go into the O-ring, it goes around it.
Got it.
Now on a normal pump, we would blow air into these two ports and it'll shift.
Yeah.
But on this one, it'll probably just piss out of here.
Oh, yep.
First test, worked. So, you want it to stroke? I put an ORB plug here. I blow air into this side. This should go that way.
Yep.
So then if I put it on here,
But you said so. You
and I blow in here,
gonna go
it'll
the
come
other
this way. Now, I don't know if I can hold it, but that's an external servo port. So with my control on here, I can put a external signal and make it shift. That's why they want those ports.
So you see the purpose of this servo is that it can just override whatever's happening inside the control. It could also defeat the control by just venting it. We're going to do a post that just shows a little example of when somebody would use this control.
And you were testing the ports that we just made.
Yes.
Here and here.
Yep. So I check it with nothing in it, make sure everything blows out.
Yep.
Everything blew out good. And I plug it, it comes back. Plug this one, goes, comes back.
Done.
Just like it's supposed to.
Charge pump.
Yep.
That's it.
That's it.
Okay, tilt testing.
Yes, ma'am. Now we're just retesting it to make sure everything is still on spec and good. We want to see our pressure jump up at around 30 psi, which is exactly what it's doing. We want to have full volume by 150 psi, and we do. So the flow shouldn't drop. So our flow comes up. Our flow holds until it hits the POR setting, then drops down to the number 3 valve setting. Pressure comes off, comes back up. Take the pressure away and it comes down proportionally with the control signal. So our control pressure comes up, holds. We hit the POR setting. The POR works on the control pressure by bleeding it off, which lowers the flow. So the flow and the control pressure follow each other, yeah.
This one is a pass. Now Lloyd and I will check. Yep, it is a pass.
Yeah.
The pumps and motors that you see on these videos, they're your pumps and motors. Send them in. We'll make a troubleshooting video and we don't charge for labor for making a video on it.